Hello, my friends. Welcome once again to the Algorithms and Olympiad track at YByte. We are back with a new lesson. We call this Applying Binary Search. We have been learning about search algorithms, and we have learned previously that binary search is, in fact, a very, very efficient algorithm to search on sorted lists. The reason is the worst case complexity of binary search scales as log of n, which is in fact much smaller than, let's say, linear search, which is linear, and say jump search, which is square root. So, log is much, much, much more efficient compared to, let's say, these two. And hence, binary search is in fact a great algorithm to be used when we have a search problem with sorted data. Of course, there is care to be taken to make sure that all the cases are handled correctly. We spoke about that in detail in the last lesson. Now, moving forward with this theme, in this lesson, we'll see a lot of problems where binary search can be applied. Now, the interesting bit is that, the problems where binary search can be applied may not immediately look like a problem where we have to search for a value in a sorted list. But basically, we realize that, look, the whole notion of being sorted has to be seen a bit more broadly. And you'll see that binary search, in fact, can be applied, right? So, to make this all more concrete, more clear, we are going to work on three problems in this lesson. First one, the flight path problem, which I've created. Basically, the story here is that, look, a plane is taking off, its height is increasing. We want to find out the first time instance at which the height or the altitude crosses a certain threshold. Next, we have this peak search problem, which is in fact, let's say, a slightly simplified version of a common, competitive problem, a competitive programming problem, where we have a data which has got a peak. We got to find where that peak is. And then we have this famous shipping capacity problem, again, one of those popular problems of practice, where we have a, let's say, a shipping company which wants to ship items, but it wants to decide what's the least capacity ship it must buy to, let's say, fulfill the order of items with certain constraints, right? So now the problems here are interesting. They have been arranged in a somewhat increasing order of difficulty. But like I said, the interesting thread or the common thread between all of this is binary search. At the first look, they may not necessarily fit into the mold where we have to search a value in a list, but we'll see that in all these three cases, binary search will in fact become a handy algorithm to, let's say, solve them. The key learning goals, as you can guess from this lesson, are applying binary search to problems that go beyond find the value in a sorted list. Um, We'll see this with examples. We'll also discuss what exactly is going on so that we can identify the conditions under which binary search can be applied. We'll write binary search code in a, let's say, in a systematic manner using helper functions, which will kind of aid us in, let's say, running this code. Now, helper function will be used, for example, in the shipping capacity problem. But the broad, let's say, point and the broad goal of this lesson really is that, we want to equip our students with tools and mental models to approach a vast range of problems. So basically, these three problems are like a starting point. But there's a common thread between all of this, which we'll highlight, and we, basically want to equip our students to kind of enable them to sort of, use these ideas into more problems. But obviously, that will happen only with practice. In fact, a lot of it. So the idea here is that let's learn the lessons from these three problems and then try and practice more to gain more expertise. Practice, remember, is the best way to learn programming. Do look at our website www.ybyte.in for more such content. Enjoy programming. Take care. Thank you so much. Bye bye.